In homework 2.1, you're taking a bunch of functions and composing them in different ways, so you can practice the chain rule, the product rule, the quotient rule, and telling the difference between them. You've got two parts of it. One is this part right here, the homework 2.1 that you're actually going to be turning in, where you're going to put the functions. Then you've got this second part where it has a bunch of functions that you're supposed to choose. I'll just kind of show you how this is going to work. For each problem, you're going to choose a random function. Like maybe for g of x here, you're going to choose tangent of x. For h of x, maybe you choose 8. Okay? And what we're doing is, whatever the rule is, it says the rule is f of x equals g of h of x. You're composing those functions in that way. So for instance, here, f of x equals g of x is tangent of x, h of x is 8, and so g of h of x is tangent of h of x, which is 8. Depending on what you pick as your functions, you should not have tangent of 8 on yours. You should not be copying down this example exactly. You should be picking them in a random order, so yours are probably going to be different than everybody else's, and that's okay. Once you have your function, you need to do the derivative of it. So we're doing the derivative of tangent of 8. I'll do this one for you, but yours will look different, so I don't know how much help this will be. In this case, you have two options. One is you can do the chain rule. You can say, hey, this is tangent of some function. So the chain rule says it's the derivative of the outside function. So the derivative of tangent is secant squared, with the inside function still plugged in, times the derivative of the inside function, which is 0. So this whole thing ends up equaling 0. Or, at the very beginning, you could have noticed that tangent of 8 is a number. You can do the tangent of 8, it gives you some constant, and the derivative of any constant is 0. That would have been fine too. This will be different from problem to problem. We've already used tangent in 8, so maybe the next one we use is square root of x. So here we get, I'm choosing square root of x here, and so this becomes f of x equals e to the g of x, so e to the square root of x. That's our function composition. And so the derivative, I would need to use the chain rule because it's a function inside of another function. They're not all chain rule. Let's look at this next one. This next one is, I'm choosing two more. I'm going to choose sine of x and pi squared. So m of x is sine of x, p is pi squared, and this time m of x is sine of x, p of x is pi squared. This is a product. These are multiplying times each other, so this is not a chain rule. Pi squared is not inside of sine of x. I could use the product rule. There is a much faster way to do this one, which is that because pi squared is just a number, this is a constant. It's pi squared sine of x. This is not a this is a constant function, and so the derivative when you have a constant function times a function is the constant multiple rule. So this is just f prime of x equals the derivative pi squared sine of x is just pi squared cosine of x. When there's a constant multiple, we just leave it there and put the cosine in front. Now, if I had chosen natural log of x instead of pi squared, then when I do the product rule, when I do this product, I couldn't use a constant multiple rule. I would have to use the product rule. So throughout, you're going to have various chain rules, product rules, etc., and you have to notice what the rule is each time. You want to be amazing at this, at being able to tell it. Some of them you even need to use two chains, like where there's a chain rule within a chain rule, or a product rule within a chain rule, and that's okay. I hope this helped.